Alright, so today we are going to talk about solving rational equations. So what we've been doing the last couple lessons is we have been simplifying our complex fractions and as well as our expressions by addition or subtraction. And now we're actually going to be looking at solving when we've got these fractional polynomials. So, our learning goal is to solve equations involving polynomial rational expressions. So meaning we've got fractions with polynomials in them. Now, you did some similar things back in Algebra 1. You solved equations that looked like this. Now, yes, you have variables here, but the difference between what you did in Algebra 1 here and what we're going to be doing in Algebra 2 is that in Algebra 2 we've got the polynomials in the denominators. Here in Algebra 1, all your variables were in the numerators. But I would just want to review, we looked at some of these in, gosh, it must have been the first week of school when we did some review of Algebra 1. And we looked at this and we said, well, you can get a common denominator and do all that, or you can make it much, much easier and just get rid of all of the fractions at the beginning. So if I multiplied this entire equation by 42, what would happen is that this 42, because 2, 6, and 14 are all factors of 42, when I multiply times that, here's what happens. 42 times the first term. Well, 2 cancels and goes into 42 21 times. So I multiply this by 21. So that gives me 21x squared. Over here, 42 times my second term. Well, 6 also goes evenly into 42. It goes in 7 times. And 7 times 5x is 35x. Since this was a minus, it'd be minus 35x. And then 42 also goes into, or 14 also goes into 42 evenly. It goes in 3 times. So 14 cancels, and then I've got 3 left over from the 42. So equals 3 times 9, which is 27. Now, if you look at that, we have made this equation much, much easier to solve because now this is a quadratic. And I really hope that by now we know how to solve any quadratic equation. We can get it equal to 0 and factor, use the quadratic formula, complete the square, all of those good things. So this we should be able to solve relatively easily. But the key is focusing in on what our first step was. And that was when we multiplied by 42, that was the LCD. So that is going to be the key to solving these rational equations, is finding and multiplying by the least common denominator. We're going to use that same idea and just kind of take it to the next level. So here are our steps. We're going to factor the denominators completely, just like we did every other time we've been finding LCDs. Then we're going to multiply all terms by whatever the LCD is, and then you're just going to solve the equation that remains. Now, like when we had our equations that involved radicals, we're going to have to check the solution because you can't have 0 in the denominator of a fraction. So you have to check for extraneous solutions. If it gives you 0 in the denominator, we have to cross it out. All right, so let's take a look here. Factor the denominators completely. Well, all of these denominators are monomials, which means they can't be factored. So I can go ahead and find my LCD so that I can multiply it. So I need an x in my LCD since there's an x here. Since there's a 2 here, I need 2 as part of my LCD. And here has x, but that's already covered. So 2x is my LCD. I'm going to multiply every term, all 3 terms. So 2x times my first term, 3 over x. When I multiply that, the x cancels with the x here, and all that's left is the 2. Notice how I write this up at the top so I remember what I'm multiplying by. So if I'm going back and looking at my work, I can see what happened. 2 times 3 gives me 6. Now 2x times my second term. The 2 cancels with the 2 here, and all I've got left to multiply by is the x. So x times 1 is just x, and since it's a minus, we're going to have minus x. Then I've got my equal sign. Make sure you multiply by this term also. Just because it's on a different side of the equal sign doesn't change that. So 2x times x, the x's are going to cancel. The 2 is left. So 2 times 12 is 24. So I think we would all agree that this is a very easy equation to solve. It's linear. So all I need to do is subtract the 6. I've got negative x equals 18. So divide by negative 1. X equals negative 18 is the solution I come up with. So now I just need to take it. Here you're not plugging in to make sure you get a true statement as much as you're just making sure you're not going to get 0 in the denominator. So if x is negative 18, none of these would be zeros in the denominator. So that is my answer. All right. B, time for you to try on your own, see if you can come up with the steps here. So go ahead and pause it and work the second one out, and then unpause to see and follow along with your work and see if you got it right. All right, so first step, factor denominators completely. Well, I need to give this a denominator. It's 4 over 1. But there is no factoring to do on this one either. X plus 1 is in simplest form, so I can go ahead and multiply by my LCD. So this has an x plus 1, so x plus 1 has to be part of my LCD. This is a 1. Remember, when I multiply by 1, it doesn't do anything, so I don't really need to write that. This has x plus 1 also. So that's it. My LCD is x plus 1. I'm going to go ahead and multiply every term by that. So when I multiply my first term over here by x plus 1, this cancels with the x plus 1 here, and there's nothing left. So I don't need to multiply the 5x times anything, because I'm really multiplying times 1. Then my equal sign. Now my next term. Nothing cancels here because this was a denominator of 1, so I would need to multiply it times x plus 1. So I'm going to do the same on the top. So on the top, I need to multiply by my x plus 1. So when I do that, you have to distribute it, remember, so we'll do that in the next step, but I'm multiplying 4 times the x plus 1. Finally, my last term here, this x plus 1 cancels with this one. So again, I don't need to multiply this by anything, and I just end up with my minus 5. So now I'm going to solve. First I'm going to distribute, so I've got 5x equals 4x plus 4 minus 5. So then all my x's on one side, numbers on the other, so move this over. 5x minus 4x is x, 4 minus 5 is negative 1. So I've got x equals negative 1. Plug it back into my denominators. Negative 1 plus 1 would be 0. So I would get 0 in the denominator of a fraction when I solve that. So that means that even though I got an answer, it's extraneous, it doesn't work, so we have to write no solution on this one. All right, so if you had some struggles with B doing it on your own, let's focus in on the part where you made a mistake here when we look through this third one. So first, factor the denominators completely. X minus 4 doesn't factor, but x squared minus 16 does. That's x plus 4 times x minus 4. Again, when there is no denominator, you probably want to give it 1, so the denominator would be 1 there. All right, so I'm just going to kind of scratch this out so I know that this is my new denominator. So my LCD, I've got an x minus 4, so that needs to be part of it. Over here, I also have an x plus 4, so that needs to be part of my LCD. And the 1 is just a 1, so we don't need to worry about that. So now multiply each term times that LCD. So the x minus 4 cancels with this x minus 4. So I'm going to be multiplying this 2x plus 1 times the x plus 4. So 2x plus 1 times x plus 4 equals. Here, my LCD is the same as my denominator, much like what I had over here. And when that happens, the denominator just cancels out, and I don't need to multiply the numerator by anything. So that's just going to be a 16 plus, Now over here, this denominator was 1, which means both parts of that LCD I have to multiply this numerator by. So 3 means multiplied by the x minus 4 and the x plus 4 here. So now I'm going to simplify. So I'm going to FOIL here on the right or on the left side. So 2x times x is 2x squared. 2x times 4 is 8x. 1 times x is x. And 4 times 1 is 4. Over on the right side, my 16 stays the same, but I need to FOIL this, which is just going to give me x squared minus 16. And then I need to distribute the 3 to both of those terms. So 3x squared minus 48. So this is quadratic, which means that I'm going to need to get everything to one side. I generally like for my x squared terms to be positive, so I'm going to move everything to the right side here. So minus 2x squared, those cancel. Then I'm going to do, this is 9x, so I'm going to have to subtract 9x. There is no like term over there, so I'm going to put it over here. And then finally move my 4, so minus 4, minus 4. So 3x squared minus 2x squared is just x squared. And then my minus 9x didn't have anything to combine with, so it stays. Then my numbers, I've got 3 of them. 16 minus 4 is 12, and then I've got 12 minus 48. So 12 minus 48 is negative 36. And I had moved everything off of this side, so it's equal to 0. So now that's a quadratic. We need to solve it. Again, there are multiple ways to solve quadratics. If it's factorable, use that. If not, complete the square or use the quadratic formula. Here, what multiplies to negative 36 and adds to negative 9, that does work. I can do x minus 12 and x plus 3. Those multiply to negative 36 and add to negative 9. So equals 0. So if x minus 12 equals 0, that means x is 12. And if x plus 3 equals 0, that means x equals negative 3. So now I just need to check them. So if I plug in 12, 12 minus 4 is 8. We're okay here. 12 squared minus 16, that's okay. So 12 is good. Try the negative 3. Negative 3 minus 4 is negative 7, so that's okay. Negative 3 squared is 9 minus 16, also okay. None of them give me a 0 in the denominator, so both of those solutions will work. All right. Now, usually when we get to the end, it gets harder. In this case, we get to the end and there's a shortcut. Now, this shortcut would not work for anything that we had in this example 1. This shortcut only works if each side of the equation is a single rational expression, meaning just one fraction. If each side is just a single rational expression, we don't even have to find the LCD. We can simply cross multiply and solve. So solve it like a proportion. That is so much easier than having to find the LCD. So on both of these, we can just cross multiply. So I'm going to show you here in A, since it's just a single fraction on the left and a single fraction on the right, cross multiply 2x times x minus 3 equals 3x times x plus 3. I do suggest actually writing it out and not skipping this step because I find that people tend to make mistakes. And again, I can give you partial credit if I see you knew what to do. So now distribute 2x squared minus 6x equals 3x squared plus 9x. So again, this is going to be quadratic. So I'm going to want my terms all together here. So subtract the 2x squared, add the 6x. So I've got it equal to 0. So 0 equals x squared plus 15x. That is factorable, GCF of x. So x times x plus 15. So set each factor equal to 0. So x equals 0 and x plus 15 equals 0. So this one's already solved, x equals 0. Down here we get x equals negative 15. So now I check both of them. If x is 0, 0 plus 3 is 3, so we're good there. 0 minus 3 is negative 3, so we're okay there. If I plug in negative 15, I get negative 12 and negative 18, so I do not get any zeros in the denominator. So both of those solutions work. All right, last one I would like for you to try. So go ahead, do your cross multiplication and solve this equation, and then unpause it, come back to check your work and see if you got the right answer. All right, so cross multiplying, I do 5 times the x squared minus 9. Notice that we don't even have to factor here. This is so much less labor intensive than the other ones when we are actually able to cross multiply. So 5x squared minus 45 on the left, 2x squared minus 6x on the right. So get all my x squareds together. Again, I always move them to the side where the x squared term is going to be positive. So that's going to give me 3x squared. Need to add the 6x. There is no like term over here, so we'll just put it in the middle. So plus 6x minus 45 equals 0. So this is a quadratic. So first I'm going to try to factor it to see if it's factorable. There is a GCF of 3, so if I take that out first, I've got x squared plus 2x minus 15. So is there anything that multiplies to negative 15 that adds to positive 2? Hopefully you said yes. It's x plus 5 and x minus 3. So we can't set this equal to 0 because it doesn't have an x. You can't just say 3 equals 0. That doesn't make sense. So x plus 5 equals 0 and x minus 3 equals 0. So x equals negative 5 and x equals positive 3. So now plug them in. X equals negative 5. So I put in negative 5. Negative 5 minus 3 is negative 8. We're good there. Negative 5 squared is 25 minus 9, which does not give me 0, so we're good there. Plug in the 3. 3 minus 3 is 0. So this solution is extraneous because it would give me a 0 in the denominator. So just x equals negative 5 for my answer here. All right, hopefully you liked that second half a whole bunch better. Don't forget about that shortcut because it takes so much longer to have to do them using this same method. So that is all for today's lesson.